So I'll just quickly explain what we're going to do in this video and the security mechanisms that we're going to put in place. So we're going to use hashing and salting. And I know you know what this is because I know you've heard about this in CDS, but I'll just quickly summarize what it is. So when you log into a web application, this could be an Angular application running in the front end, and then a backend application, which could be a REST API. And what the user does is they log in with some sort of unique identifier like a username and a password, or an email and a password. And then the REST API is now responsible for actually authenticating the user. And the way this is done is using a security mechanism that stores the username and the password securely in the database. So we say that we don't store passwords as plain text. So of course we do store it as text, but the text goes through a mechanism we call hashing. And hashing is also what we call a one-way function. And it is called a one-way function because you cannot unhash something that has been hashed. So take for example a user that has password 1234. This 1234 password needs to be stored in the database, so when they log in, we can figure out if they truly are who they claim to be using their password. But the database might store something completely else. And why are we interested in storing something completely else? Well, if the database ever gets attacked and there's a data breach or something, there will be no harm done, because you cannot log in using this value. Because the function that logs a user in would now take this value and put it through the hashing function and get some completely other value, which is not the same as this value. So in order for us to log in, we need the actual password, which then gets hashed into this value. And because it is a one-way function, we know that it deterministically will always produce this output. And there is a security concern in that, because what if two people have the same password? Well, then they have the same hash value, at least if they're using the same hash function. The immediate threat exists because what if someone takes, let's say, 1 million different sequences of characters and just puts them through the 10 most common hashing functions? Well, then they have 1 million hash values of passwords. So if there ever is a data breach, they can just look through all of the hash values and compare them to the values in their own pre-hashed values. That's also what we call a lookup attack, or a dictionary attack, or a rainbow table attack. And the security mechanism to cope with this attack is called salting. So what salting is that inside of the database, next to the hash value, so let's say this is the hash value, so let's just write hash up here. So imagine this is a database, and we now have a column here called salt, and salt also has a value. And salt is not generated by the user itself. The salt is by the backend application generated randomly for every single user. So what is actually happening is that now the user will send their password to our program, and our program will now take their password and add a little sequence of completely random values onto their own password, thereby making it completely unique and very long and secure also. So we're actually artificially making a new password for them behind the scenes, and now we take this new password and we hash it, which means every single password that will then be inside of the database, we know that these are unique passwords, and they are also very strong passwords. So the concern that someone should have pre-hashed values that just happened to correspond with these salted hash values are now very, very, very unlikely compared to before. So of course, if everyone in the world makes secure passwords, we wouldn't need salting. Salting exists because people are very bad at making passwords. They're very bad at making long passwords, and they're very bad at making unique passwords. And those are the two things we really want from a security standpoint. So what our application is going to do once we have our salting and hashing in place is that we're going to make a token. And we're going to return this token to the user. And the entire idea behind the token is that once the user then starts to send some new requests, say they want to get a list of products here. So we say get products. What they attach to this GET request inside of a header is a little token that identifies themselves, so that we on the backend here, we can verify that they are authentically themselves when they supply this token. This token might contain values like the username and the ID and the role of the user or whatever. And thereby we can figure out, is this an admin? Is this a normal user? Who is this? And only us can verify this, because you can encode and decode a token, but there is a certain part of the token that requires what we call the secret. And the secret is a password that is encrypted with the remaining data of the token. So the token can be encoded and decoded anywhere. You can take any JSON Web token and you can put it into a decoder, and you can figure out what kind of data is put into this token. But the secret you will never be able to know, because it is not simply encoded, it is encrypted. So a part of the encoded token is also encrypted, which means that we can now verify the token here on the backend, and then we can return a list of products to this user. There's a very cool site called jwt.io that demonstrates this. So you can put in a token here. They just give you a default token when you go to the site, and then they pick an algorithm for you. Let's just pick this one. And there are multiple parts to the token. This is the header, this is the payload, and this is the signing. So if you decode this token, you can see that this header here will let us know that we're using this algorithm and it's this type of token. And this is the data we put into the token here. So there is a name, John Doe. Let's change this. So it says Alex Uldal. Now you recognize that this payload is changing out here. But not only that, try and see what's happening to the signing here. The signing also changes, which means that if I reforge a token, then the signing changes, right? And what's happening when we verify the signature? I just put in EASV here as a secret, right? Only the backend will know this secret. That's why the backend can verify the token. If we change the secret here, of course, the signing part here also changes. So that's what we would expect. But the important thing is that when we change the data inside of the payload, that the signing also changes. That's the mechanism that ensures that you cannot reforge a JSON Web token without destroying the JSON Web token. And that's why this is a secure mechanism. We're just going to continue working on the same code base as before. So if you want the exact same code base, what you can do is you can either just clone the GitHub repository, but the problem with that is I'm going to continue contributing new code to that, which means that when you clone it, you'll get the newest version. So if you want the version from the previous video, what you can do is you can go in here and you can click on the commits here, and then you can just find the previous commit. So by the time you're watching this video, there'll probably be a new commit here, and it's going to be called something like user authentication. So just click on the commit before that on this one, and then you can browse the repository at this point in time, and you can just download it as a zip. Then you don't get the Git folder, but you don't need the Git folder, so you can make your own repository if you want to. Another thing you can do is you can go down here and you can see I have a release called CDS Auth. And CDS Auth just takes the source code at this point in time. So you get the same as if you download it with a zip, but you get it at a certain point in time always. Another thing you can do is you can still use the command line interface. We can just start off by making a repository, and I'm just going to call it CDS. We're going to CDS, and the command we're going to use looks like this. So it's still a git clone, but after the address we add branch CDS, and then we add this little flag called single branch. And now if we go into the repository here, it'll say no branch. And the difference between this and simply cloning it using the download zip from GitHub's website is that here you'll actually have a Git folder. So you just pick whichever method you want to pick, and then you can work on the same code base that I have right here. And even when I make new contributions, you won't get the new version, you'll get the same version as I work on right here. So I think we should just go through all of the security stuff from the first line of code to a fully implemented user authentication. And we're going to start off with the backend. So we have to store this hashing and sorting values inside of our database, which means that we need to start off by creating a new table, and this new table is going to be called user, and user is going to contain all of the hash values and the salts, and also the unique identifier like some kind of email or a username, and then of course a primary key. So the first thing we're going to do is we're going to create the user table. So we'll just go into domain, and we're going to add a new class. We call it user.cs. And inside of user, we're going to put all of the columns. So, well, it's properties that are going to turn into column because we're going to be using entity framework, right? So we can start off by just making public int ID get set. And we can have public string email get set, and public string hash get set, and public string sort get set. So this is what we need, right? And we can go into our DB context, and I think we should start off by renaming this. So let's just call it database context, because it's not just about products anymore. And on purpose, I don't call it DB context because there's already something called DB context. So it's just to eliminate ambiguity. And inside of this model, we can use the model builder to define a primary key. So we can just say entity, user, property, and we're just going to pick U for user, and we're going to say ID value generated on add, so it auto increments. And down here we're going to make a DB set user, and we're going to call it user table get set. So now we're ready to actually make some queries, and I think we should go into our infrastructure project here and now make a user repository.cs. So I always make repositories based on the name of the tables that they query. So we have, of course, a user entity, and it's very easy to just say, okay, the user repository is focused around the user entity. So we might have something inside of our programs called authentication service or whatever. An authentication service uses user repository, but I don't call the repository authentication repository. because the data that the repository is focused on is the user data. It might be data that is used for authentication, but it's just a naming convention that our repositories should reflect the domain models that they are focused around. So we can make a constructor here, public user repository, like this, and we would like our database context to exist as a private read-only instance variable, and we can just call it context. And we're gonna inject this one into this constructor. So we'll say database context. Context equals context, like this. And one adjustment I'd like to make to the model is that our users' emails, they should be unique, right? Because two people cannot have the same email. So I'll just go into the context here, and using the model builder, I'm gonna say entity user. And here we'll have to make a database constraint. So the way that we make these constraints is using what we call indexing. So we can write has index, and now we reference the column, and now we write is unique, like this. So there are no longer two different users that can have the same email, right? And now we're ready to make our repository methods. So they don't have anything to do with authentications themselves. They just care about returning users and creating users, right? So we just have two methods we need. And the first one is a public user, get user by email. And we're just gonna say string email. And we're gonna import user. And inside of the scope, we're gonna write return context user table first or default. And now we're gonna reference the email like this, email equals email. And then in case we could not find any, we're gonna throw a new exception, throw new key not found exception, like this. And you can put some text in here if you want. There was no user with that email, or with email. And the second method we need is just to create a new user. Public user, create new user. And you have done this before by now. User table, add user, and remember, save changes, and now we can return the user like this. So that's really all we need from the database. So because we're using the dependency inversion principle, what we want to do is we want to create an interface for this. I know that typically you would create the interface before you actually create the methods, but this was so simple, we just had these two methods we need. But we'll just go ahead and create the interface for this. So we're going to put it inside of application. We actually have a folder here called interfaces. We'll just put it in. And we're going to call it user repository.cs, like this. And we can just copy the signatures, right? Because we don't really need to define that ourselves from scratch, like this. And we'll import user, right? And what we can do now is we go into our user repository and we say that this implements user repository. And from here we can go into program.cs, and we have these dependency resolver services. So we can go into this function where we register our infrastructure things. So we just add scoped here, and add the interface and add the service user repository like this. And we had to add this. Yeah. And this is perfectly fine. But I find that a lot of people find it to be counterintuitive to have this dependency resolver service. If you don't want to have this, what you can do is just you can delete all this. You can delete the entire file if you don't want to have it in the folder that is inside it. And you just say delete and go into program.cs, delete this, and you just paste it like this. And you say builder.services. And here builder.services. And you just import these. And that's it. We can do the exact same thing with the application layer. If we copy this and delete the dependency resolver service like this. So I just want to demonstrate to you guys that this is the exact same thing. It really doesn't make any difference. It's just a design thing to take this code and put it somewhere else. But if it's more confusing for you, then I think we should just stick with this. What this add scope does is it just provides that this service is capable of being called through dependency injection for other components inside of our system. So inside of our controller, for example, the product controller.cs can get the iProduct service. Why? Well, it's not because we manually inject it. It's because we're adding this iProduct service in here as scoped. So therefore, anytime we have a constructor, we can require an iProduct service. So what I'll do now is I'll create the controller for the user authentication. So I'll create a class here called authentication controller. And just because this would be a very long name, I'll just call it auth controller.cs. So this auth controller.cs has to implement controller base like this. And we want to give it some kind of base route. So we say route, and here we make the square brackets, say controller. So when we want to call some method in here, some endpoint, we'll write auth / and then whatever route extends from there. And we'll also add an attribute that says API controller. And now we're ready to do the dependency injection. So here we'll say public auth controller. And inside of here, we will put an authentication service, but we haven't created that just yet. So I'll start off by just making two methods here. There's one for registering and there's one for logging in. So I can make one here that says public action result login. And I'll just return null for now, and I'll make another one that is called register. And both of these will require a username and a password. So what I'm going to do is I'm going to make a DTO for a user login, and I'm going to call it user DTO.cs. And we might actually have several DTOs in here. So I will just rename this file and pluralize this by writing user DTOs. So there could be several in here. And then the first one is just going to be called login and register DTO. And this login and register DTO requires an email and a password. So I'll say public string email get set public string password get set. So notice how that very little of the contents here actually one-to-one correspond with the table that we have for users. So the domain model here, it has hash and it has salt and then it has email, and then it has an ID. But none of these things, except for the email, are actually properties that we care about in terms of the data that is going to be sent from the client to the API. And that's why the DTO here really makes sense for us. And now inside of the controller, we can require this DTO. So I'm going to say login and register DTO, and login and register DTO. And now we're ready to create the service that these controller methods will be calling. We'll put the service methods inside of the application layer. So we'll have something called authentication service.cs. And this one will implement an interface called authentication service. And we can just create this interface in here. And we import this one. And the only two public methods we'll have inside of this interface is the one for logging in and the one for registering. And both of these functions need to be returning the token. And the token we can just express as a string because it's just a sequence of characters. So I can say public string register, and this one requires a register user or login and register DTO, and then make public string login and register DTO. So of course we use the same DTO because it's the same fields that we require, right? We need an email and a password. It doesn't matter if we're registering or if we're logging in. And now this authentication service can implement the interface. And now we have these two empty functions here, and we can just go ahead and create a constructor, public authentication service. And this authentication service needs to know about the user repository, user repository, and we will make an instance variable, private read only, user repository. So we can now use the user repository, right? And the register function. What's so special about this one? Although it has the same signature as the login function, the register function needs to check if the user already exists or not. So we need to figure out is the email in use. So we can just call the get user by email in the user repository to figure out if the user exists or not. And in case the user doesn't exist, then we're gonna get an exception. So we're gonna wrap the statement inside of a try catch block. So we're gonna say try repository get user by email dto.email. And now we're gonna catch the exception. And it was a key not found exception. And in case the email is already in use, we can just throw an exception outside of this block. So we can write throw new exception, and we can say username, or it was email dto.email is already taken. So what we need to do inside of this block is we need to generate a salt value, and then we need to take the password from the DTO, and then we concatenate these two. So we just combine them, take one string and put another string next to it, right? And then we hash this value and we put it into the database. So we store both the salt and the combined hash value of the salt and the password. And that's what we're going to do inside of this. But we need a library first. We need something to actually perform the hashing operation. And we're going to use something called bcrypt. I know you might have used other packages, but I find that bcrypt is probably the easiest one to perform this operation with. Bcrypt, and I actually think they call it bcrypt.net.next. And here it is. And we just add it to application. We don't need to add it to the API or anything else. So what we do now is we say var salt equals random number generator dot get bytes, and we need to figure out how many bytes do we want to use here. So of course, the longer salt value we have, the more secure it is, because the more unlikely it is that any two users will end up having the same hash value. So if we get something like 32 bytes or higher, that's considered to be very secure, and we can just store it as a string. So a lot of systems, they will store salt and hash as an array of bytes, but you can also do it as a string. Now we can just create a user object here. So if we say var user equals new user, and we need to import reference to the user model, and we can say email equals dto.email, salt equals the salt value we just created, and now we need to insert the hash value. So I write hash equals bcrypt net bcrypt dot hash password. And inside of this function, we're going to put first of all the password from the data transfer object, and then we just concatenate it with the salt. The salt is already a string, so it's no problem. So now we're ready to actually insert this user into the repository. So we say repository, create new user, and then we just throw this user object into there. And now we're ready to return the token. So we're going to create a method for that one, and we're just going to call it generate token. So public string generate token. And right now we can just return null. And up here we're gonna say return generate token. And the token needs some inputs. So of course we're gonna put some of the user's data into the token. And therefore we'll just inject the user into here. And we're gonna say requires a user object. And for us to actually generate a token, we need to use a library for it. And it's this one and also this one. So this one is called Microsoft Identity Model Tokens, and the other one is called system.identitymodel.tokens.jwt. So you can just install both of these into the application project. First of all, in order to generate the token, we need to use what's called a secret. So right now we don't have a secret. I'll show you just in a short while how we can generate a secret just like we have environment variables. But for now we'll just have a sequence of bytes. So we can say encoding UTF-8 get bytes, and here we'll just say secret, and we'll call this key. And now we're going to make what's called a security token descriptor. So we can call this variable token descriptor equals new security token descriptor, and inside of here we'll put first of all what we call the claims, and the claims are the data we're injecting into the token. So let's say we want to send the email inside of the token. What we do is we write subject equals new claims identity, and here we can actually make an array, and we can put any number of claims into there, and we can say new claim, And we're first of all gonna give this claim a name. So we're gonna call the first claim email, and then we're gonna put the value to that claim here. And since we injected a user object here, right, we can just take the email from the user object. So this line will make sure that we have the user's email inside of the token. And now we need to define how long this token is gonna last, because tokens have some sort of time expiration. So the way we make the time expiration for the token is we just write some kind of timestamp. So we can say date time UTC, and then any number of days or months or years or whatever. So let's say we want this one to last a week. We can just say add days 7 like this. And then we need to make what we call the signing. So we have something called signing credentials, and we're just gonna set this equal to new signing credentials. And in here, we're gonna put new symmetric security key. And remember, we had this variable here we called the key that is a byte array of characters. So we're just gonna put this key in here. And we need to define which algorithm we're gonna use. So there's something called security algorithms dot, and then you pick an algorithm that you want here. And this is enough for us to create the token. So once we have this token descriptor here, the security token descriptor in and of itself is not the JSON Web token, but we need this to create the JSON Web token. So we can make something called the token handler, and the token handler then writes the token based on the descriptor. Token handler equals new JSON Web token handler. And then we can return token handler dot write token handler dot create token, and then we put the descriptor into this method. So there's a lot of things going on inside of this function. You could theoretically divide all these things into many different functions, but I think it's probably easier to have a one coherent function that does the entirety of the token generation, just to conceptualize what each function inside of this class actually does. So making the login function is much faster and easier than making the register function. What we have to do is we have to find the user in the database. So we can say var user equals repository get user by email dto.email. And then we verify that the password that they sent us is the same hash value when we combine it with the salt as we have stored in the database. So the way we do this is we use bcrypt for it. I can write if bcrypt.net bcrypt verify, then I say dto.password plus user.salt, and then I make a little comma here because this is the first part. This is what we have to compare to what we have as the hash value in the database, user.hash. So what this function does is it performs another hashing. So it hashes the password plus the stored salt, and then it compares if it is the same as the stored hash value. If it is true that it is the same as the stored hash value, we know that we have a valid login. So here we can just return generate token based on the user, because if it is a successful login, then we return a token. So if it is not a successful login, we can just throw an exception. Throw new exception, invalid login. And that's it. So previously I said that we need to have a secret injected. So we're gonna go back to what does that mean. So it means that inside of our app settings here, we can add some kind of password really. So it is something that we should not share with the outside world, which means that if you put it in here, you need to make sure that you have your app settings.json set to get ignore, so you don't push this to GitHub, right? So anywhere in the first level after these outermost brackets, you just write app settings like this, and then you make another curly brackets and you say secret, and here you put your password. So it has to be a fairly long password. For this example, we can just write secret a bunch of times. Of course, you should probably have something that's a little stronger than just writing secret a bunch of times. And we can go into the program.cs now. And now we need to make use of this secret that we have inside of the app settings.json. We're going to use the builder.services for this. So there's something called builder.services.configure. And here we'll make something called app settings. And inside of the normal parentheses, we'll write builder.configuration.getSection. And here we'll write app settings. So remember, app settings is the thing we wrote right here. And secret is the thing we have inside of app settings. So we're going to find a way to actually find the value for this key inside of our app settings file. So right now there is no such thing as app settings, but we can just make a helper class. The way I like to do it is I like to make a new empty folder. So I'll make a directory here called helpers. And inside of this, I'll make a class and I'll just call it helpers.cs, or you know what, I'll call it app settings.cs, and then the class will also be called app settings. And I'll make a property here, public string secret. Like this. And now we can import app settings, which means that now other services can make use of this one here. So if we go into our authentication service, this is where we actually need the secret. Inside of the constructor, we can require the app settings. So the way we do it is we write options and make diamond brackets, and here we write app settings, and we can just call this app settings. And we actually need another package for this one. So if you go into the NuGet package manager, we need something called Microsoft.extensions.options, and we can add this one to application, and we should now be able to import this options, and we can make an instance variable private read only app settings. And here we will set the app settings equals to what we have in the input dot value. And now we want to make use of the secret that we have inside of this. So we can go down where we had our key, and then we can say app settings secret. So now instead of just hard coding a secret here, we're actually getting the secret from the app settings that are getting the secret from the app settings.json file in here. We have a couple of changes we need to make to the program.cs file. Right now we still haven't added the authentication service, so we need to do it here. Builder.services add scoped. And here I can write authentication service. And now if we go into our auth controller, we're ready to fill out the constructor and the methods that we have in here. So we can start off by making an instance variable private read only authentication service, and we can just call it auth, and we will require this and set the instance variables equals to this. And for the login function, I will wrap it inside of a try catch block. So try return OK auth.login with the DTO, catch exception. We can give this one a variable as well, so we can return it. Return bad request e.message. And it's essentially the same we'll do for the register function, but just calling the register here. And we also need to define the routes for these endpoints. So the route for login is just going to be login, and the route for register is just going to be register. And we're also going to declare that this is an HTTP post, and so is the login. So one modification I'd like to make before we start working with the front end is that the HTTPS redirection, I will at least temporarily remove that. And that's because you might get into some trouble with the backend rejecting some of your requests due to security concerns. So what this line does is that if any client requests, let's say, port 5000 on the HTTP server and not the HTTPS server, it will try to redirect it. But since you don't have a SSL or a TLS certificate set up, you might also get rejected. So in order to circumvent this, we can just remove this line right here. And in case you don't add the development mode flag in your .NET run command, you can just take this and leave it out of the is development here. So now cross-origin resource sharing will always be enabled. There are some people who will still get problems with cross-origin resource sharing. There are different ways you can write this statement, and one of the alternatives is options set is origin allowed, and then you can say origin and this little arrow, and then write true, and then we can delete this, allow any origin, and then you can write down here options dot allow credentials. An alternative syntax for this is to just chain the functions together. So you can say options dot set is origin allowed, then we do what we did before, and then you can just, instead of saying options dot, you just make a dot here, allow any method dot allow any header dot allow credentials. And now you should not have any problems with your backend request rejecting your request from your front end. So once we're ready to start sending some requests, we can open up Postman. And if you have not sent any requests yet, you probably need to rebuild the database. So we just send a request to the endpoint in the product controller called rebuild.db. Of course, it doesn't have to be inside of the product controller. It really doesn't have anything inherently to do with products because it rebuilds the entire database, but it's just there temporarily. And now we can start sending a post request. So we will post to the auth controller, to the register endpoint. And now we need to create a user. So down here, we just add whatever email we want. So any string here and any password string as well. And now we send this to this endpoint and we get a 200 response back. Of course, in real life, you would probably make this a 201 because this is a creation and not just a read. But the important thing is we get this token here. We can copy this token. And now we can go back into our browser. And if we go to JSON I'll make sure to fit this in the view. And we paste our token here. We can see that this token belongs to peterdoe.com, which is what we entered when we registered. And we have this expiration time here. So this expiration time is exactly 1 week from now, because that's how we generated the token in the generate token method. And it will also say when it was issued, and it was issued just a little while ago. And if we enter the secret here from our program, so jwt.io doesn't really know what our secret is, right? So if we take our secret from the app settings.json here, it's this very, very secure sequence here. Put it here. And then we take our token here. We'll see that it says signature verified. So if I start changing the secret here and still have the same token, it will say that it is an invalid token. So right now we don't have anything that actually protects any routes. And what that means is that we can get a list of products even if we don't supply a token. So what we would like to do is to make some kind of authentication middleware such that certain routes in our controllers, they will require a token, such that in order for us to get the products that we have at this route, we would need to go into authorization, and then we would have to insert a token like we did right here. But right now we can delete this token and click send, and we still get a 200 OK. And the way we do this is we go into program.cs, and then we write builder.services.add authentication. So we of course have something called authentication service here, but authentication service is our own classes, and they simply just issue tokens and they perform hashing or whatever. This is something we need to use for securing the endpoints. So this is something that actually restricts the user from making requests that they are not authenticated for. So inside of this add authentication, we're going to add something called JWT bearer defaults. And this JWT bearer defaults is inside of a package called Microsoft ASP.NET Core.authentication.bearer. So we need to find this NuGet package, authentication.bearer. And we have it here. And we need to add it to a program that to the API here. So we'll do it like this. Once it's added, we can import this one. And after adding authentication, we'll write add JWT bearer. And we'll need to put some options inside of here. So these options are all of the options that will check the token that is attached to the HTTP request. So the way we define these options is options.token validation parameters, and we set this equals to new token validation parameters. And we can just go ahead and create a scope right away. And now we're going to fill out the token validation parameters. First of all, there are some default Boolean values that we have to change. they have something called validate audience. And the validate audience is by default true, and we're going to set it to false. There's something called validate issuer, and we're also going to set that to false. And we're going to set validate issuer signing key to true. And now we're going to supply this signing key. So it needs to know what the secret is for us to actually figure out whether or not any given token is valid. So we're going to put this into the issuer signing key. So we're going to write issuer signing key equals new symmetric security key, and inside of here we're going to put the secret. What we can do is we can write builder.configuration.getValue, and here we can also say that this is a string we're looking for, and we can write app settings and then colon secret, just like this. And we're gonna make sure that this is actually read as an array of bytes. So we're gonna write encoding UTF-8 get bytes. And now that this is surrounded by the get bytes statement here, we have everything we need in order to create the token validation parameters. And now we're ready to actually enable the authentication. Right now we're using the builder, but remember the builder is not actually the application. The application is called app. The builder is simply the recipe for the app. So now that we have specified the app here, we're executing the application down here. And right between enabling cores and mapping the controllers, we're gonna call the use authentication here. So this is the line which enables everything that we've added up here. Right here, we're just adding authentication as a kind of middleware. And once this is added, we're enabling it down here. And we also have to enable authorization. And authorization is slightly different than authentication, and we'll get back to what the differences are. But we do have to enable use authorization because we're going to use an attribute called authorize inside of our controllers. So right now we don't want our login and register endpoints to be protected, but we do want our product endpoints to be protected. So you cannot get a list of products unless you're logged in, but you should be able to log in without being logged in. That makes perfect sense, right? Because by the time you're logging in, you don't have a token yet. You're calling the login to get a token. And then once you have the token, you can then get products or create products or whatever. And we're ready to run the program now. So we'll just rebuild it. And now we're gonna rerun it. And we're gonna go into Postman again. And this is the endpoint we're using to log in. So I just tested it previously. If we log in with, let's say, peter@doe.com, password this, and we're sending this, we're getting this token back. So we can copy this token, and we can go into the get products here, and let's just minimize this, and we go to Auth here, and we're gonna put in the token here. And now we're gonna get a 200 OK response, which means that when we're supplying a token, we can read all of the products. And let's say that we change the token here, and we're sending this. Now we are unauthorized because we're sending a token that is not valid any longer. And now we're ready to implement the front-end part of the system. I just opened up the front-end folder. It's simply just a folder inside of the Onion symbol repository. And the first thing you should do when you open this one up is to just write npm I. This one installs all the dependencies. And now once it's done building, you should be able to go in here and see that you have a node modules folder. So if we look at anything that requires a dependency, like the HTTP service, which requires Axios, there should be no red lines here. So if we delete the node modules folder again, we can just get it back by writing npm I, and temporarily we wouldn't be able to run the program because all of our dependencies, they would be unbuilt. But now that we have installed the dependencies, we can just write ng serve. And first of all, I'd like to just make one modification. We disabled the HTTPS redirection. So I'm just going to use HTTP localhost port 5000 instead of HTTPS port 5001. And this is just due to cross-origin resource sharing. You might not get any problems with port 5001, but in case you do, this should be able to help you. Inside of the app component, right now we just have one component, but I think what we should do is make two components. So if we go into src and then into app, we can create a component for logging in. So we're just going to call it login, and this stands for ng, means Angular, G for generate, C for component, and then this is just the name of the component. And I'm also going to make a component for products. So instead of having products inside of app component, I'm going to make products inside of product component. And the first thing I'm going to do now is take all of the things that is really just product stuff, and then I'm going to put it inside of this one. And since app component also has all of the product stuff inside of the TypeScript file here, we can just copy this, delete this, and then paste here, and that's it. And of course we want the app component to know about the product component and the login component. And the way we do this is through routing. So if we go into the app module here, we're going to create an array. And this array contains a number of routes. So we can just declare our array as being a constant. We can call it routes and say that this is a route type. And the first one here, we're gonna input something called path, and path just specifies a relative route. So it could be products, and now we're gonna specify the component for products, and it's gonna be product component. And next up we have the login of component, of course, path login component login component. And inside of the app component here, we're going to put something called router module. And router module just determines what is going to be opened at this point. So depending on the URL we have inside of a browser, this might be showing the login component, or it might be showing the products component. If we go back into the module here, we're gonna add something called routing inside of the imports here. Specifically, it's called router module. So if I say router module for route, and now pass the routes into this one. Routes, and then make a comma here. If I now open up localhost port 4200, and here is the front end, and if I go to /products, I now get to the front end that we built for the products. And if I go to login, it will say login works, because if we go into the the login component.html, it says login works right here. So we're going to make a UI for the login. And the way that I would do this is using Angular material. And I'm just going to show you the process of actually creating a UI, because I use this library and there is a lot of good documentation inside of this. So in order to make the login page, what we would need is some kind of input field. And there is something called input here. If you click to the input, and they have some examples. So there is this example here, and you can just click at the view code here. This is essentially what we want, right? It's something where you can enter a password and you can enter a username or whatever. So take the code here, put it into the login component here. The outermost tag, the form tag, we don't need. The form tag in and of itself, it doesn't supply anything visual, but there's a lot of front-end stuff using HTML that will put things inside of forms. And you can also do it that way. I prefer to just use what's called ng model. So I also used ng model in the previous video. The way it's done is using this syntax, and then you just make a variable here. So let's make an email field. Create field email. And we go back into the login component here. And there's something called text area here. Text area is slightly different than simply input. So we can just take this input here and put it here. And we say password. So now we have one field that is our email field. There's a little label here, and we're just going to call this label email. And we're going to remove the placeholder. The placeholder is just the text inside of the field where nothing has been picked, and we also don't need this one. And for the password here, what I'm going to write is an attribute called type. And if you write password inside of this type attribute here, the characters, they will become hidden, so you don't see the password in plain text. And we can just call this one password. Right. And let's take a look at the front-end's login component now. It's going to reload, and then we have an email field here, and we have a password field here. So right now they're next to each other. I'd like them to be on separate lines. So I'm going to insert this little BR tag here. This just means breakpoint. It just makes a little line. So now we have an email field and we have a password field. And we're going to make a little button down here such that when you click the button, it's going to perform a login or a register or whatever. So I'm going to make the button here, and I'm going to write met raised button. And the text on the button you can put in between the tags here. We're just going to make login. And what happens when you click it is you trigger a function. So I'm going to make a function called login. And now this login function is going to call the HTTP service. This HTTP login. And if you remember from last time, the way we do dependency injection is just write the name of the variable that you would like here, and then the type HTTP service. And right now there is no login function. We can just create it like this. I like to make the functions asynchronous because I use Axios. So I can write HTTP result equals await custom Axios. So custom Axios simply just defined our base URL up here. So custom Axios dot post, because we're sending a post request, and then the route is auth/login. And we also have to supply the username and the password. So we can just call that DTO, and we can create a DTO here and say this is simply any. And now we return HTTP result.data. And then the login function here needs to take the email and the password, right? So I'm gonna write let DTO equals email this email, password this password. And now we'll just put the DTO into the login function, just like this. And once we've logged in, we can say that var login result equals this. We'll have some kind of data here. And I think we should just start off by just logging the login result here. The login result should be a token. I think we should maybe call this token. And we'll just check that we get a token in the front-end application. So if we open up the browser here, and I don't quite remember what we put inside Postman. We put some random password, I think. We can just find the random password that we made for peter@doe.com. peter@doe.com. Put the random password in here. I'm going to open up the console here. Now when I click login, I get this, and then I get this token here, right? So I successfully log in because I get a token. And if you take a look at the networks tab here and take a look at the login, we can also see that the response is here. So anytime you're trying to debug your front-end application and you're sending some HTTP requests, you can always see what's going on by just opening up the networks tab and then take a look at things like your headers, your payload. So this is what we're actually sending. We're sending email and password, just like we did in Postman. And then we can see the response here, which is this one. So now we're going to get to the point where the front-end security actually happens. There is something called local storage, and we're going to need local storage in order to store the token, such that when we start making new HTTP requests, we can find the token inside of the local storage. So I'm going to write local storage here. I'm going to write set item token, and then just write token. Let's do like this. So now we're actually waiting for the response. So the alternative is that we're sending a request, but we might not actually have gotten a response yet. So just remember to use async await when you're calling something that uses a promise. And here you can see that the signature for the function that we're using to log in is a promise. And now we get to maybe the most important part about making this token thing work, and that is attaching the token. If you go into the HTTP service and scroll up to this custom Axios thing, we can create something called headers here. So if you pick headers and make a scope here, we can pick authorization. And now what we will write is bear, and then you make a little sign like this, and you make curly brackets, local storage, get item. And remember we called it token before. So now we're looking. Local storage inside of the browser is simply a key value store, which means that at this key there is a certain value, and the value is the token that we stored. So right now we're saying for the headers, for all of the HTTP requests being sent from the Angular application, we're gonna add authorization. So let's take a look at the application now. we can log in again, peter@doe.com, and the password here. And let's just take a look at the networks tab, just to make sure that we got a successful login. And now let's go to products and make a new product here. Test prod 1, 2, 3. Click me. And now we got test prod, which means that we are successfully capable of sending HTTP requests because we're attaching a token. Let's say that we go into our application now and we are removing the authorization header here. So we're no longer attaching a token, and we go into our front end, and now it's refreshing. We start clicking. This is unauthorized, right? So we don't have a token. Therefore, we're getting a 401. Now that we have successfully added authentication to our application, what we would like to do is add what's called role-based authorization. So now we're back in the backend here. And what we have to add now is the user's role. So we have to store this role in the database, which means that we have to edit this user class here. And I'm just going to make a string called role, public string role, get set. And now this role, we have to add this role to the token somehow. So the way we do this is we go into the authentication service, and the data that we put into the token is the claims. And this is the line that we're interested in editing. And inside of the curly bracket here, this is the inputs for the array containing the claims. So just after the first claim here, we're just going to write new claim, and we're going to write role, and here we're going to put the user.role. So now when we generate the token, not only will the token contain the email, the token will also contain the role of the user. The next thing we have to do is we have to enable authorization inside program.cs. And we're going to be using the builder for this. So we're going to write builder.services.add authorization. And inside of the parentheses here, we're going to have some authorization options. And these authorization options can contain multiple of what we call the policies. So a policy could be that an admin has certain privileges over a normal user. So let's say you want to have privileges for creating a new product that are different from just reading products. So any user can read a product, but only an admin can create a product. So that's what we specify here, the policies. Options.add policy, and here we're going to give it a name. We can just call this policy admin policy. And the notation here is that we're going to be calling something called policy.requireRole. And requireRole simply just looks at the token, and then it looks at the role and then the value here. So if the value at the role inside of the token is now admin, this user will be authorized to, for example, call endpoints that are marked with the admin policy. So let's take a look at how that actually works. If I go into my controller here, we already have the authorized attribute, but we can put some strings into this authorized attribute, and then we can write admin policy. So now not only will you need a JSON Web token to actually call the endpoints in here, but you will also need a certain role inside of the token. So we're not interested in using the same policy for everything, so we'll just have authorize up here, completely empty like this, and then for a post request like this, we can use authorize and now admin policy. There is a modification we should make before we start sending any requests, and that is the login and register DTO needs to also require a role of the user that we are registering. So let's say we're making a new user, we need to figure out, do we make this user as an admin or as a user? So here we can write public string role get set, and inside of our authentication service here, when we're creating the new user, we should also be adding the role here. So I can write role equals dto.role. And now when we're saving it into the database, we're also saving the role along with the user. And since we don't need the role in order to log in, we just need it to register, we can go into the DTO and then we can say that this is optional using this little question mark here. And now I think we should rebuild our program here. And we can run it and open up Postman. And now let's make a user called admin@do.com. Password 1234. Role is admin. And before we get this far, I think we should just rebuild the database because we've been making changes to the database schema. And of course, we're getting an unauthorized here because the rebuild DB is actually a protected route. So what you can do here is either you can make sure that you're logged in order to rebuild the DB by putting a token inside of your authorization header. Or what you can do is you can go into your endpoint here with the rebuild DB, and then you can write AllowAnonymous. And if it has the AllowAnonymous attribute, you won't be required to supply a token. So now technically anyone can rebuild the database. So it's not very secure, but it's just for development purposes. And now we successfully rebuilt the DB. So this one, which doesn't have a token that belongs to an admin, will get a 401 unauthorized. Whereas this one, which has a token that belongs to an admin, can send this one and get a 201 created. So now we're successfully protecting routes using roles. So right now inside of our front end, anyone can go to the products and anyone can go to the login. But let's say that you want to make sure that not only are you not able to get a successful response from the API when you perform certain actions in the front end if you're not logged in, you might also want to make sure that you cannot even get to this route if you're not logging in. So we have something called auth guards, and these auth guards make it impossible to navigate to a certain route if you're not logged in or if you don't have certain credentials. So we're gonna look at how we can enable auth guards. And the first thing we need is to use a library in order to decode the token inside of our Angular applications. So there's this thing called JWT decode. We can install it using this command. So we just copy this and we open up the terminal here. And we just have to be inside of the front end folder here. And then we can paste it. And now that it's done installing, we're gonna create a service inside of this front end program. So we do have a folder called services right here. And we can go into this folder. And now I'm gonna create the service using the ng-generate service. And we can just call it auth guard. And by default, it also creates a testing file, but we can just delete this one. And inside of this AuthGuard service, we're going to implement an interface. And it's going to be called can activate. There's also one called can load that is very similar to can activate. The difference between the can load and the can activate is that it's possible to load a certain component without necessarily activating it. But we're just interested in, can the user navigate to the route? So I use this can activate interface here. And you get this method once you implement the interface. And although the signature looks very complicated, there's a lot of stuff here. The only thing we have to do is we have to return a Boolean depending on whether or not it is allowed for the user to activate this route. So we're going to use the JWT decode library that we just installed. So we can write up here, import JWT decode from JWT decode, like this. And now inside of this can activate, we will write the logic behind whether or not they can activate the route. So let's say we just want to check if the token exists. What we can do is we can write let token equals local storage get item token. And then we can write if token return true, else return false. And now it's probably going to say that we can simplify this by just writing it this way. And let's just check this one. So the way that we enable the AuthGuard service is we go into our module, which has all our routes. And here at the path, we're going to add something called can activate. And we have to make square brackets here and put in the AuthGuard service. So what this essentially does is it says we're going to protect this one route here using the interface in here, and the interface has to be implemented, and we're returning true if there is a token here. So the way we can test this is we can open up a browser. So right now we are logged in, which means that we can go to products. But let's say that we open up a browser in incognito mode. We don't have a token inside of this browser. So we can go to localhost port 4200 and go to /products. And notice what's happening here. We're getting navigated away from the products because we're not logged in. If we logged in here, log in, and we say admin boy, or I think we would just call it admin, at sto.com 1234, log in, and we now go to products. We're here, right? Which means that we have successfully been checking if there is a token, but we're interested in figuring out, is the token valid? And the way we do that is, let's take a look at the token real quick. So here is the token from the admin user. Let's just copy this token. And we go into JWT.io, and I'll just show you this in a more visual way. So we have the expiry time here, and we have the issued time here, which means inside of our authentication guard, we're going to figure out if the time right now is before or after the expiry date. So if we take a look at this timestamp here, we have to make sure that the current time is not past this one. So let's check if a token is expired. So tokens are set to last 7 days for our system, which means that the expiry time put inside of a token, I have it right here, is set to be at this point in time. So that is Friday, October 28th, and it is issued at Friday, October 21st. What we have to figure out here on the front end is the current day that we have right now before or after the 28th of October. And I'm going to make a class down here for the token just so it's easier to actually reference the properties inside of the token. So So I'm going to say class token, and I'm going to make a variable here that is a number. So exp is the expiry time, just like we had it right here, and it's just a simple number. You could also put other things in here like role or whatever. And now I'm going to say let token equals local storage get item token. And what I'm now going to do is I'm going to say let decoded token equals JWT decode token as token. And right now it's going to complain that maybe this token is a null. So we can just say if token. So if this token thing is not undefined, I'm going to be able to do this successfully. And now we can reference the exp property here. So you see we have this thing, and we're going to create two timestamps using what's called date inside of JavaScript. So I can say let current date equals new date. So it's automatically going to be creating a timestamp here for this current point in time. So at this very second, when the user is checking the route, it's creating a new timestamp. Let expiry equals decoded token exp. And now what we're going to do is we're going to say if current date is greater than expiry. And here we actually have to write new date. And inside of this, we're going to multiply this by 1000. And here it's going to say it's possibly undefined. You can just suppress this with ts ignore, or you can check if it is or is not undefined. So you can say if decoded token.exp, and you just make a scope here. So we have a lot of scopes right now. Thanks a lot, JavaScript. And here we can say return false. So if the current date is a later point in time than the expiry date of the token, we're going to return false. We can just flip this as well. So we can say if it is earlier in time than the expiry date, we can return true. And then return false down here. So this is how I would check if a token is still valid. So you could also be checking based on the role. So let's say that you put role here, string. You could also say if current date less than expiry and decoded token dot role equals admin. Now you would have to be both an admin and have a token that is not yet expired. So we can just check this really. Let's go into the browser. We have it right here. And it is successful. So let's say that you want to make sure that you have to be a super admin in order to access this route. We can no longer access it because we're just a normal admin, right?